Hello, LabVIEW enthusiasts. Hooovahh here. I just wanted to make a quick video demonstrating some of my VIM array functions and some of the things that they can do. To find this package, go to vipm.io. You can search for Hooovahh or Array or VIM, and it'll probably all come up. Here's a Hooovahh Array VIM. Click Install, and you'll get all these nice palettes on your LabVIEW block diagram. So I thought I'd show off a couple of the functions that I find the most useful. Here we have the foreign key sort, which is found on the main palette right here. And what it allows you to do is sort one array based on the results of another. So here we have the keys going in, we give it an array, and then we sorted the keys, but we also sorted this other thing and gave it a new pointer. One time you might use this is something like this, where you have an array of students, you have an array of grades, and you want to sort them. So here we sorted the grades, and then we rearranged the student names based on how the grades were. And returned will also be this sorted pointer. You can sort the 1D array itself with a separate function here, which is under the OpenG palette, or you can use this foreign key sort. Because all of these functions are VIMs, or malleable VIs, that means that we're actually able to provide any 1D array to either of these two. The outputs are obviously messed up because they also change, but if we change that around, now when we run it, it's actually sorting the student names, and the grades get rearranged based on how the student names are changed. Another function I like to use is this force 1D array min or max size. Here I have an array constant with 2 elements in it, and I'm telling it to make sure that it has at least a size of 5, adding elements to the end. So then when we run it, we can see here it has my 2 elements, but then it added these 3 zeros to the end. We could choose to add it to the start instead, or we could say the maximum size needs to be some value, and it'll trim from the end or from the start. So if I say it can only be 1, it'll trim from the end, or it will trim from the start of this input array. And that again is on this root of this palette here, force 1D array min max. Here is a conditional auto indexing, which is not all that special, but it does return both the true and false values. So here I have false, true, false, and it will return the falses here and the trues here, and I can rearrange these however I like. So these two arrays kind of have some association where their number of elements are the same. Here is a filter 1D array. So here's some input, and I gave it a constant saying filter out empties, so it did that. But what's nice about this is we can give it a 1D array, maybe filter out everything, and now when we run it, it should be empty. It also has an optional input mentioning no duplicates, which is an addition over the OpenG function, and that's just for some performance enhancements. That function happens to be in here under the OpenG VIMs. Same with the remove 1D array duplicates. If we give it an array, it can remove any duplicates that it finds, and it will return the indices of those duplicates that it removed. Here is a delete elements from a 1D array, from a 1D array, which is not all that special. It's just that it allows an array of indices to delete. So here we can see I want to delete index 3 and 4. So 0, 1, 2, 3 gets rid of the DD, and the 4, oh, there isn't even a 4, so it didn't do anything. Not a very good example. Sorry about that. Let's try this. Oops. And now it's complaining about unwired inputs. There we go. Now it deletes those 2 indices that I mentioned. It also has this optional input saying if the indices are ascending already. If so, then we can avoid the sorting function that needs to take place there. One last function I wanted to mention is that this sort 2D array VIM, which is on the palette right here, NI already has a sort 2D array function on their array palette, and it's probably slightly better in performance than the Hooovahh one, I'll admit. But the Hooovahh one does return the sorted pointers and it lets you choose the ascending or descending order of the sort that is taking place on the column or row for that 2D array. But otherwise, they serve a very similar purpose. The rest of these functions are very similar to the OpenG equivalents. So like the 1D array, it'll return an array of all matching elements, not just the first matching one. Let's see, yeah, I did add these two, which is indexing 2D arrays on rows or on columns, as opposed to this function, which you have to provide an array of essentially rows and an array of columns, and it will pull out the scalar values out of that 2D array. But everything else is very similar to what the OpenG array tools are, so if you're familiar with those, these are drop-in replacements. And then up one palette is a bunch of other things that I added, and that's where you'll find some of these foreign key sorts and 1D arrays. But again, another major benefit over the over the standard OpenG ones is these are VIMs. They are malleable VIs. So that means like this array needs to be a 2D array, but it can be a 2D array of anything, and this function will be happy. It can be a 2D array of a cluster of a string of a Boolean, and it will be just fine. You can have type defs in here, and the outputs will be type defs. That's the major benefit of these malleable VIs. So if you have any questions, feel free to post on the LAVAG forum, which will be linked in the description.